In this segment, which is our first, or actually it's our second segment, but this first one, we're going to be talking about network diagrams as far as calculations. And what I'm going to do is I'm going to show you kind of a little bit of the background information, and you're going to say, huh, and then I'm going to start working through an example network diagram, and hopefully some of that first stuff you're going to see in this segment will make it just a little bit more sense. So let me give you the stuff that's going to be more of a kind of confusing, and then we'll jump into hopefully something that's going to be a little bit clearer, but not necessarily totally clear. But the good news is, or maybe the bad news, but the good news is we're going to do this a number of times over the next weeks to come, so that you'll start to get the hang of it, and you can kind of do it perhaps with your eyes closed or in your sleep or whatever the case may be. These are called constant time networks. We really call them just network diagrams, and there are nodes. And again, this is just language that you'll start to see in the following example. These are things, and don't worry about this parentheses A thing and parentheses B, this parentheses A thing. That's not really we don't really use those parentheses. And you'll see what I'm talking about in a minute. But we have four things that we really are tracking in network diagrams. The first one is the early start, and that's really the earliest you can start a particular project. And you'll see that in the diagram. You have the earliest you can finish a project, the latest you can start an activity, and the latest you can finish an activity. And you say, okay, yeah, okay, I don't know really what you're talking about, which is fine because we will see that in the example. When we go this way, left to right, that's really when we do the early starts and the early finishes. Again, you're not going to know what these are until we start working through them. And then after you go through them, you go from the end and you go backwards, and that's when you calculate the late starts and late finishes. And again, just bear with me. And we also are looking for what they term the critical path, and it's the one that takes the longest time to complete. And I'll tell you right now, and I'll emphasize it later on as well, but the critical path is important because it's the one you have no wiggle room in. It's the one that you say, you know what, we have to hit everything right on the money for us to get this done. It takes us 5 days to do this path, and it takes us 4 days to do this path. So the critical path is the one that takes the longest. That'd be the one that took 5 days versus 4 days. Because this path, I could goof around in on one path, and even a day, like in the example I just mentioned, and I still could get done on time because one path gets done sooner than the other. So, all right, let's go ahead, and that's why we care about the critical path. It's the one that takes the longest, and if you mess up and you have any sort of delays, it's going to make you get done later than you had originally planned. Okay, I'm going to jump over to another screen where we're going to work at an example, and I'm going to be hopefully talking about these terms as we go. All right, here it is, and I want to try to make it big enough so you can see. Let's see if I can make this any bigger. I don't want you to lose track of, and of course this is your notes, and it's worked out before, so I'm going to scoot on over to my thing so I can work here. Oh, let me get my stuff arranged. So I'm going to show you how this is connected up here. See this activity A? This could be something like I'm going to cut a piece of metal. And they're doing it this way, decide on a topic, collect data. But you could be in a business thing, it could be you cut a piece of metal, you send that metal over to B to drill a hole in it, and you may set you could send you could take this piece of you could cut this piece of metal here, and then you might send half of the pieces. You may come in the big pieces and small pieces. You may send the big piece over there to have something done to it, let's say bent, and you may send the small piece over here to have it drilled. And then Then you may send both those pieces, the bent piece and the drilled piece, back here to be be put together. And so that's kind of, and that's why sometimes there's critical paths. Is you may have, when you may cut something in half, for example, and send a portion this way and send a portion this way. In this case, they said activity A, decide on the topic, and it says go there to collect data and there to search the internet, which doesn't make a whole lot of sense to me. So I don't really like this approach. And then you write the report, because you really are not necessarily doing both of those somewhat in the same, at the same time, or you could do them at the same time, just because it's just you doing it. So anyway, so I'm going to go ahead and get started. By the way, this A1 indicates that it takes 1 day. So that's activity A, and it takes 1 day. Activity B takes 2 days, and that's why the 2 is underneath it. Activity 3 takes 3 days, and C takes 3 days, and activity D takes 5 days. It could have been 3, 1, 5, 2 days. It's not like it goes from smallest number to biggest number. Just however long it takes to process it. So what we do, and I'm going to do it this way to begin with, and then we start to take kind of more of a shortcut. So this is always the format. Okay, I'm just putting these in here ahead of time. And so, and the ES for the E's, ES's and EF's, E's always, when you're going this way is, whoops, when you're going this way is when you are calculating your E's. When you're going this way is when you're calculating your L, your LS and LF, but we'll get to that in just a second. So I start off here with my activity, my first activity, and I'm just getting ready to start off. So I ask myself, when's the earliest I could start this? When is the absolute earliest I could start this? Well, I could start it right now, which is really, time 0. And it takes me 1 day to finish it. So if I could start it right now, I could finish it 1 day later. So the earliest I could finish it would be 1 day later. So far, so good. Not a big decision thing. So then what I do is I kind of follow my arrows, and I say, well, if this process is done in 1 day, the earliest it can get done is in the first day, then when's the earliest I can start this one? Well, I can start it right now. I can start it as soon as I get it done. I can start it after a day. So this is right now. In a day from now, I'm done. So in a day from now, they can start working on it, and it's going to take them 2 days to do it. So 1 plus 2 is the earliest I can finish that one is the 3rd day. And then I say, okay, when's the earliest I can start this one? Well, the earliest I can start this one is 1 day from 1 day and after the first day, because this was right now, 1 day later, I am done with it. So they can have it on the first, after I finish it 1 day later. And so I say, well, when's the earliest I can finish this one? Well, I can say I'm going to get it on after the first day, and it's going to take me 3 days to do it. So 1 plus 3 is 4. And that's fairly straightforward, okay? But here's the next part, is that I have this one that could be done after the 3rd day. This one can be done after the 4th day. So when can I put the 2 pieces together? And you say, well, you can put together the 3rd day. But it doesn't work like that, and here is why. Think about this. Let's just pretend that putting this part together is these 2 steps. Okay, so I have after I'm done with B, my pen looks like this. After I'm done with C, I'm just making this up. My lid looks like this. So on the third day, they say, I'm going to send this pen over to here. Okay, because we're done with it. And then they say, and your job is to put the cap on the pen. That's the final step, is to put the cap on the pen. And they say, all right, I got this in the third day, but I cannot do anything until I get this piece, these pieces. So I have to wait to the fourth day to get it in order to put the part together. And so the answer to this one is the earliest I can finish it. I have to wait for the one that takes the longest. So I have to say I can only start this on the fourth day because I am waiting on this part to come to me. So when's the earliest I can finish it? 4 plus 5, that's a 5, equals 9. So the earliest I can be done is day 9. Now, that's the E's. ES's and EF's when I say E's. Now we have to go this way to do the LS's and LF's. So here's the thing is this number and this number are going to be the same. Oops, I forgot to. I'm doing the shortcut already and I shouldn't do the shortcut already. I'm just going to write LF equals 9, LS equals 4. And you say, well, where's that 9 come from? Well, it ends up being just the same thing as this, okay? And you say, well, all the numbers are going to be the same, and you'll find that that's not the case. 9 is at the earliest I can finish it is 9. The latest I want to finish it is 9, if you want to think about it like that. So I say 9 minus 5 is 4. Same, and it will be. And then I go, well, then I do my LF, and I do my LS here, and I do my LF, and I do my LS, and I do my LF, and I do my LS. So far, so good. So it says, the latest I can start this one is on the fourth day, okay? It says, the latest I can start this is on the fourth day. Well, if I have to start this on the fourth day, when's the latest they can get these parts to me? When's the latest that they can get these parts done? Well, the same day that you need them. The same day that you need them, which is the fourth day. And I say 4 minus 3 is 1. That latest I can start them is the first day. You say, well, these numbers are the same. Okay, you're right. The latest I can start these is still, I need to start this activity on the fourth day. So the latest I can finish this one is on the fourth day. Okay, but because I have to start this on the fourth day is the latest I can start it. So therefore, this has to be done on the fourth day. So I say 4 minus 2 is 2. So now our numbers are different. This is 1, this is 2, this is 3, this is 4, whereas this is 1 and 4 and 1 and 4. And this is 4 and 9 and 4 and 9. And there's significance to those numbers in just a second. So now I have a decision, and you say, okay, the latest I can start this one's the first day, the latest I can start this one's the second day. When's the latest I can finish this one? When's the latest I can finish this one? Is it the first day or the second day? Well, in order to meet this deadline, the tightest deadline, I got to have this done in the one that needs it quickest, soonest. So I say, well, that one needs it after day 1. This one needs it after day 2. So I have to go. I need to get this done so I can get those parts down there in day 1 because they'll need it. And 1 minus 1 is 0. And now I'm going to show you a shortcut, but in just a second. I'm going to show you a shortcut in just a second. But when you have, this is just a informational thing. When you have This is what I do. This is only for the ESs and EFs, the early starts and early finishes. When you have when you have two arrows feeding into a circle, like here, okay? Whenever you have two, you have to make, and I do this, and I recommend you do this. It keeps you from getting into trouble by making assumptions that are not necessarily true. Whenever I see two arrows feeding into a circle, I know I need to make a decision about an E. I need to decide, do I use this E? Do I use this EF of 3, or do I use this EF of 4? And so I had to make the decision, okay? In a similar vein, when I have two arrows backing into one node, two arrows backing into it. See, these are two arrows pointing to it. These are two arrows backing into it. I have to make a decision on which L to use, and so which LF. And so like on this one, I had to make the decision, do I use this one or do I use this one, okay? Because see that arrows backed into that one. I had to make a decision about which one of these L's to use. And I recommend strongly that as soon as you get one of these diagrams, that you go ahead and identify the ones that have to make decisions about L, and the ones you have to make decisions about E. You don't have to make a decision on this one. You don't have to make a decision on this one because there's only one coming in and one going out. So, but these two you have to make decisions. Now, here is the other little useful piece of information is when you have to decide between the two, you choose the bigger one. Well, just like here, the E, remember doing the E's, this EF is 3, this EF is 4, you choose the bigger one, okay? You choose the bigger EF, okay? And on this one, if you haven't guessed already, you will choose the smaller one. And to keep this in mind, remember, smaller has an L in it just like that has an L in it, okay? Smaller has an L and that has an L. So like in this one, we had an LS of 1 and an LS of 2. I chose the smaller, the LS. I put that number right there. And so that's how it goes. What does calculating the LS and LF do for us? It tells us if I look at this, if I just did this by hand, and you can do it on the simple ones, it gets harder on the harder ones. I have one path that I could go. I have my material flows this way. Some stuff goes this way. Some stuff goes this way. So I can go A, C, D is one path to get to the end. And I also have A, B, D is my other path. Okay, I have two paths to get to the end on this one. So my A is if I look at this path, I go for the ACD one, I go 1 plus 3 is 4 plus 5 is 9. That one takes me 9, ACD. This one takes 1 plus 2 is 3 plus 5 is 8. This one takes 8 days. This path takes 8 days to complete. This path takes 9 days to complete. The critical path is the one that takes the longest, which is, I just said, this one, and this one. That is the critical path. This one is your critical path. It's the one that takes the longest. And so what does that do for me? What does calculating this stuff help me do? Well, guess what here? The critical path, this number is the same as that number. 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 But look at this one. This number is not the same as that one. This number is not the same as that one, so this one is not on the critical path. This one is not on the critical path. So it tells you which one you can goof around a day on this one and still get done on time. But if you goof around on any one of these and you make like a day or two delayed, if you have to spend an extra day here because of something that's not working right, you're gonna get done in 10 days instead of 9 if you spend an extra day here, or if you spend an extra day here, you get done in 10 days instead of 9. Or if you spend an extra day here, you get done in 10 days versus 9. If you spend an extra day here, you're still going to get done in 9 because you have a day to spare on this one. It's not on the critical path. Okay. That's a good place to stop on this segment, so I'm going to stop it.